this is a video dedicated for assembly workbench only. My friends, welcome to my channel Focusing FreeCAD. Today I want to work on the FreeCAD assembly workbench. As you all know, the new FreeCAD 1 version, which is today I'm using FreeCAD 1 release candidate 1. So previously it was FreeCAD 1.2, the stable version, and recently this release candidate 1 came out, which is a major milestone for FreeCAD and its user community, also the developers obviously. So today in this new version I want to work on the dedicated assembly workbench, which also is new for this FreeCAD 1 version. Yesterday I was thinking about this thing where I could say a circular motion can be converted to stepping motion. I don't know what it is called, but the idea is I will be rotating this wheel and that motion will be converted into something like digging into the soil, right? Like the farmers do. So this is kind of backhoe in the back of an agricultural attachment. So I was thinking about this and I thought like maybe I could use this idea to come up with, say, a modified idea where I could come up with something like this. Right, so here what we have is we have gear assembly, and the whole idea will be this is set up in the back of a tractor, and then a machine will be rotating this handle, and that way these arms will go up and down. Right, so there is the idea. Here's what I were planning to do, and let's go ahead and delete this assembly altogether. And because I want to show you all what what's the main idea of this video, like coming up with an assembly. So I am going to hide each of these and explain how I build this model, or like why. So it will be a quick short introduction to these parts. So this is the fixed part where I'm planning to have 4 of those digging holes in the back. So this will be the fixed part, and then there is this actual part. This part will be doing all the digging into the ground. So this is the base, this will be the actual part. So these are the 2 things that we need most. And then this strut will be fixing this hole, so that way it's not like dangling around, it's not a cantilever, it will be supported at this support. And then as a driving mechanism, I want to have one big gear that will be rotating this whole thing, and there will be another small gear that will be focused or more on the driving force. So this will be connected to the motor and it will be rotating. Now it is a smaller diameter, this is a bigger diameter, so the motor will be having high RPM, but actual the RPM will come down to smaller number. And then this is the drive shaft, so that will be connected to the motor, and this is kind of something to hold them together, not much of a big deal. All right, so these are all the parts that I have, and I will upload this model onto OnSailLens, where you can download it and then play it around with your ideas. So don't worry too much about the sketching and how I build this model will be available to you for playing around. So with all of that, let's go ahead and hide this and start our tutorial on assembly workbench. So the assembly workbench will come, what they say, assembly workbench will be shipped with the package. So it will be, once you install this 1 version, you will have the assembly right there. And we start with having a assembly holder in there. So create an assembly first. And before I do that, I hide all of my parts there, right? Because I don't want to get confused when I keep adding those in here. Also, I can, if I wanted to, I can keep all these parts in a separate file and then have the assembly in a separate file as well. Not sure if there is any specific benefit to that, but that's possible as well. So I have the assembly. Now notice that this is like written normal assembly now, which means that it's not activated. So double click on it, go ahead and activate that, or just right click on it, activate project. It's not activated. Without activation, the assembly will not work. And by default, there are the origins, which we don't care too much about. I'm sure there's more to it, but for now, let's not worry about the origins right now. And then there are the joints. We'll get back to there and then do some work on this as we go forward. But these two comes default, and origins, not to worry about, something for the developers to worry about. And the joints, yes, we will have to worry something about it. All right, let's go ahead, add our first part. So as I said, this is the idea file that I have opened, so I can pull in parts from there as well, but we don't want to. So, but the first thing I want to add is the base. As I mentioned in my couple previous videos on the assembly workbench, it is very important to have your parts named appropriately so that you can see what part you're adding to. So go ahead, add the base. In mine, I added the base and then it is grounded. It is fixed in place as default. If you don't have that set up, go ahead and click yes on here. So that will be grounded. So one part must be grounded in an assembly workbench. So it is better to start with the grounded part to begin with. This can be toggled. This can be changed later on. There can be more than one grounded part in an assembly, but just know that there must be one. So let's go ahead and add that one first. And then I want to add, let's say I want to add the gear holder. Right? I added that, and there it is. I can move it around if I wanted to. Or I can do that later on as well. I can just grab it and then put it anywhere I want. All right, this is my, as I mentioned in a second ago, this is my third video on assembly workbench, maybe fourth, I don't know. So today I'll definitely have Revolute joint, fixed joint, and maybe one cylindrical joint there too. No sliding joint, which is pretty easy. So I'll have these. Those will be like a side project, but I'll be mostly talking about the gear joint. So let's go ahead and add these parts. So this is a gear holder supposed to be fixedly placed in here in this hole, something like that. So what I want to do, I want to start with this. So because that will be a fixed joint, start the fixed joint from here. Know that you can change the joint type from here later on, but for fixed joint I'll start from there and then select the first surface that I want to say fixed with, because there is like moving involved. So I want to select the first solid part which will not be moving, right? And then create the second part. Just make sure this is axis, the Z local axis stays in the same direction. So here, now did you notice what I did? Let me do it again. So create the fixed, and then I'm taking this edge as my mating part and this edge not here. If I take it, it will be stuck right there. I can change the offset anyway, but I would rather take this one so they mate right there. All right, now I don't want to have any rotation right now, no offset needed, but if I wanted to, I can change the offset as I need. All right, and that is my fixed part. Pretty cool. I want to do that 3 more times on here. So I will add that same part, this gear holder, 1 2 3, so it says 3 inserted, and then I'll just repeat what I did there. So maybe I did not have to repeat it second time on the first one because I am doing it here again. If you feel like it is a little fast, I'm going a little fast to follow as a beginner in this assembly part, please let me know. I will try to adjust my pace. And this is the last one. Pretty cool. All right, so we got that part taken care of. Now I want to add the gears. I have it as big gear, so I will add that 4 times and then add it right here. So into the insert, I can just go ahead and hit I on the keyboard and then big gear 1 2 3 4. I added 4 of those big gears right there. And now I will do what, because I want this gear to revolute to be able to rotate, I will add this revolute joint. Here I want to take this edge, right, keeping that Z, that blue Z that pointed towards the left, that Z in my mind, and then something like this. So if I take this, see, if I take this, that will be and then I'll have to do the offsetting. Sometimes we need to do that, but I can get away without doing that here. So I'll take this, that's the edge, and then I'll take that inner part, right, that inner part. So if I took that, the offsetting part, I don't have to worry. All right, so let's see. Now looks like we have that gear moving with the axis right there. Pretty cool. Let's go ahead and add the rest of the 3 gears. There it is. We have our 4 gears connected right there, and all of them are moving. All right, so my idea is I'll place this. So this is the lever placed on the gear that will be driving that digging part, and I want to distribute that. So, but I'll do it later on. But the idea is one of them will be at the bottom, one of them will be at the top maybe, and this one will probably be on the other side. So now we have 4 different positions, so they will be like in a zigzag motion. All right, let's go ahead and add the shaft in there. So I want to add the shaft that will be the driving force, and that I have named as drive shaft. Pretty cool. Now this driving shaft will have a bearing at this place, so there will be 4 bearings, right? But I'm just guessing, I don't have to worry about all that 4 connections. What I will do, I'll just take this revolute joint and take this edge, right, this one, and take the, okay, so it's not, see, now it shows that the z-axis is facing outward, so this is not matching up, but it kind of placed falling together. I'm still trying to figure out that axis direction. There is no way I can flip it around, and it will come play a role in the gear joint later on. But for now, what I want to do, I want to offset it towards somewhere here, so it covers this gear. Yeah, I think that's okay. So what I have now is I can take this one and then rotate it. So it's a revolute joint. I can take it around. Now this is the only way this rotates. I wish there was an option for numerical input as well. I'm sure it will come up in newer versions, but sometimes it becomes an issue to rotate like this, and I want to have precision rotation. So having kind of like a window here, say I would go 5 degrees, 7 degrees, and 20 degrees, something like that. So now I have the drive shaft and the big gear done. Let's go ahead and start working on the smaller gear. So the smaller gear will be fixed to the drive shaft, which will be driving this bigger gear. So I want to add the small gear 4 times. All right, and then fix it at 4 different places right here. So there will be a fixed joint, and then I want to say I want to take this edge and this edge. All right, so now looks like they both of them has the Z at the same direction, which is leftward, which is important because you see, remember, the bigger gear has this Z on the left side, so we have to make them both on the same direction, this local Z on 2 gears. Now if it is fixed right there, if I rotate this, if I rotate the drive shaft, the gear will be moving too. Pretty cool. The next step is to apply the gear joint. So now if it is moving like that, you can see the smaller gear is moving, but the big gear is not, because we haven't done any relationship between them. So to do that, before I want to go ahead and kind of like place them by hand. And also at this moment, I want to show you how I designed these two. So these two teeth will fit in. Let's go to the big gear. Let's take a look. So there is the extrude, there is a cut because I made the hole. And there is this gear that I created using the gear workbench. And in there, right in there, I discussed about this gear building in my last video. I'll leave the video in the description below. But in there you can see the DW is called the pitch diameter is 30 millimeter for this big gear. So when it comes to the radius, we will say that is 30 divided by 2. For the smaller gear, the radius is, so the DW is 10 millimeters, the radius will be 5 millimeter. We want to remember those two numbers. All right, now I can go ahead and let me hide this so I can see the inside of that gear. And then I want to apply a gear joint and select this first. So this edge, or like the inside, either way. But remember to look at this Z, local Z, and also here. So these two Z's are facing the same direction, which is very important. Otherwise it will not work. It will be rotating in the different direction. And then the radius 1, we selected the smaller one, so that's going to be 5, as we just showed you. And the bigger radius would be 15. What it does is, now if I rotate this, the smaller gear will be rotating uniformly, or even the other way. If I rotate this the other way, so for this to happen, the both of these gear will have to have the same module, and also the radius is very important. Let's take a look at the drive shaft and see if the drive shaft is moving the big gear. Yes, so if I move the drive shaft, the whole mechanism is moving. So let me do that 3 more times. All right, here as you can see, the 2 axis is not in the same direction, so I can go ahead and flip it. And there is a smaller gear. Well, there is another one from the previous one, so let me offset it just a little bit. So this is the one that we are making, but the axis are like, you know, the axis needs to be on the left side for this to work. So keep that in mind and offset it to its location. We want to fix it in place. Another note is that see how I fixed this on the either sides. I want to do it right now before it is too late. So this is on the left side, this is on the right side. These two will be top and bottom. This shaft, this tiny little shaft. All right, so we have all the gears set out there. Let me bring the gear holders back. Now this is the complete setup for that part at least. And now let's see if it works. If I rotate the shaft, all the gears are rotating the way they should be. Right, so we can see from here it's easier from to rotate like this, and that's actually rotating all four large gears, which is very good. Right, so now let's focus on the rest of the work, which is to attach the working piece. And what I will do, so I will attach it right here. It will be another revolute joint, and I'm going to go ahead and insert that piece 4 times. Right, and I guess I'll start working from here. Take a revolute joint, take this edge and place it right here. Okay, and flip it around. Nope, keep it like that, and then bring it over here. Rotate like that. Okay, so that's one done. We will do it 3 more times. All right, so that 4 pieces are placed in their position. Now what I did is I made this 5mm thickness, same as this thickness. So now the levers are facing 5mm outward, which will come in handy in our next phase. Insert this strut, this triangle, that inclined bar, maybe 3 more times. Right, so there is 3 more, and then there is 1 more, 4 times total. Like here we have 2. Okay, what I want to do, so in theory, this will be connected there with the revolute joint. This will be connected there with the revolute joint. Now I made it such a way they align perfectly, so I can go ahead and do that revolute here. I don't want to overwhelm the software. Talking about the supporting system, one of them revolute, another one of sliding, the cylindrical joint would still work, and I guess that's what I'll do it. So if I take a revolute joint and take that edge, this edge, right, and then place this edge in there, so that kind of mates in right there. All right, and this one will actually rotate 360 without any deviation left or right, so it will just rotate because it's a revolute. With that we can have a cylindrical joint just to keep ourselves out of the woods. So I want to have that as a cylindrical joint, but in theory just know that this will be a revolute joint. I don't want to have any over constraining thing right there. Right, so we got that one. Let's see how that works. So I rotate this, and that hole, that piece, I don't know what is the exact technical word for that. So the digging piece will dig into the ground based on where it is. Kind of tough to rotate with the lever, but it's easier with the bigger axis. Okay, So looks like it is working. So the idea is the drive shaft will drive this smaller gear, which will drive this bigger gear, and that will start digging into the ground. Something like that. Pretty cool, huh? All right, so let's do that for 3 of them, and then we'll do a final demonstration. All right, so that's it. That's actually all the connection we wanted to make. Let's see if I can rotate these. Let's see. So if I can go, so this lever is making a little tough for me, but I wish I could do it like pretty quickly. Let's do it from this way. So now I can go ahead and rotate the thing, and that will distribute the digging effort into the ground one at a time. As you can see, those digging parts are getting into the ground as we rotate. I wish I could do that from this view, but this lever is a little too short. Let's see if I can make that lever. So here is the drive shaft, and I go in there. There's the cylinder. This is the extrude. Yep, that's the one that I want to make it longer. Can I make that, say, 60? Does that break anything? It did not. Okay, there it is. Oh, pretty cool. So there is your topological naming issue gone, or like eliminated to some extent. And double click on the assembly, see if this longer gear is helping me. To some extent, yes, but still, I wish I could do that numerically. Say, change the values. All right. So you can see there's the idea. You can see the idea from here. I'll just take one of the gears and try to rotate it. All right, there it is, folks. There is my digging attachment into the ground that will be fitted on the back of a vehicle, mostly agricultural vehicle. And then if you are living in an 1860 or like in a prehistoric time, you can have someone sit over there and then rotate it by hand, or like just fit it with a motor and then do it mechanically. Anyway, my focus was to show you how the gear joint works in this assembly workbench. Obviously, I already said I would be happy if I could rotate this gear shaft, this drive shaft, a bit smoothly. But other than that, you can see how beautifully this thing is moving around, and for which I am really happy for this new assembly workbench. Anyway, so as I promised, I'm gonna go ahead and upload this model onto on-sale lens. I'll do that right now. So I'll just go on to lens.onsale.com. I have myself logged in already there, and then it is easy to upload. Even if you wanted to upload, I am uploading my 200 3D model series in there as well. I'll just go ahead and upload this one as well. So here is the file, fresh out of FreeCAD. Double click on that, and this should show a preview of what it will be uploading onto the website browser. There it is. So there is my model, and you can download this one. So I cannot actually show the assembly right here. I can download this model and then play it around as you want, practice on it. and the link will be, so this is going to be the link. I will place this link in the description of the video. All right folks, that's it for this video. If you have any question, comment or suggestion regarding this FreeCAD, how to approach it, if you are a beginner, how to handle the assembly, or like, you know, if you have any suggestion how to improve my workflow on this, please let them know below in the comment section of this video. Thank you for those comments as always, and I will see you in one of my next videos then.